Hey kids, solving rational equations, algebra 2 video. Nirvana. I was in the 8th grade when Nirvana became no more because Kurt Cobain died. I don't know, I'm just in a Nirvana mood this morning. Alright, let's jump in. This shouldn't take us too long. Let's get started. Okay, a rational equation contains at least one rational expression. Remember, a rational expression is one that includes a fraction, an algebraic fraction. And remember that when you have an extraneous solution, that's one that's derived from the original equation, but it turns out it's not a solution, usually because it causes a zero to appear in a denominator. We're going to do the same kind of thing we were doing with rational expressions. We're going to utilize a least common denominator. And in these, what we're going to do is multiply by that least common denominator on both sides. So you'll notice we have x minus 3x plus 3 and x squared minus 9, which is convenient because that is a difference of squares, and that's exactly what x plus 3, x minus 3 gives you if you multiply it out. So we're going to multiply both sides of this equation by x squared minus 9. So what's that going to do? Here it's going to cancel and give you just a 2 on that side. I'm going to move way over so I have enough space. But over here, the x minus 3 will cancel, but we'll still be multiplying an x plus 3 through the numerator. The x plus 3 will cancel on this term, but we're still multiplying an x minus 3 through that numerator. So we have x times x plus 3 plus x times x minus 3. Then we're going to simplify it down. Minus 3x, so those 3x's are going to cancel. And we have 2x squared equals 2. And x, therefore, if we divide both sides by 2, x squared equals 1. And x is plus or minus 1. So our solutions are positive and negative 1. Now, real quick, before I say that for sure, let's double check. If you plug in a 1 or a negative 1 here, here, or here, are we going to end up with a 0? No, we are not. So that takes care of that. Next one. Okay, another example. So we're going to factor this first numerator here. So x squared plus 3x plus 2. When we factor it out, whoops, a doozy. And erase. There we go. 2. That's x plus 2, x plus 1. So again, it's actually the same kind of situation we had on the last one. So we're going to multiply everything by x squared plus 3x plus 2. But you can think of it, if you want, in the form x plus 2, x plus 1. So that's what we're multiplying everything by. So on the first term, it cancels out and we just have x minus 1. In the second term, the x plus 2 cancels and we have x plus 1 that we have to multiply. And on the third term, the x plus 1 cancels and we have x plus 2 that we have to multiply out. So we're going to multiply out and simplify down both sides. Uh-oh, sorry, you caught that, didn't you? Random equal sign. Not an equal sign, it's plus sign. There we go. X squared plus x minus 2. All right, we're going to get everything on one side and factor. So we're going to subtract the x squared. It's going to give me 1x squared. Takes care of that. We will combine the x and the 2x, make 3x, and then subtract this x, so plus 2x. Minus 1, add 2, so we're going to have plus 1 equals 0. And when we factor that, we get x plus 1, the quantity squared. And that means that x is equal to negative 1. However, look up here. What happens if I plug a negative 1 in there? I'm going to get a 0. And since x equals negative 1 was the only solution we came up with, it turns out, since that's extraneous, this equation has no solution at all. Next one. Okay. Least common denominator here is x plus 2, so we're going to multiply both sides by x plus 2. I've been using all these same colors here. Let's change colors. So the whole thing times x plus 2. What happens? On the left, it cancels the denominator, and on the right, cancels the denominator. Let's get everything on one side by subtracting x and adding 1. Subtracting x and adding 1. And we get 0 equals x squared plus x minus 2, that's factorable, that's x plus 2, x minus 1. equals 0. We get x equals -2, and we get x equals 1. Remember to test them out, and as soon as you go up there and you test them out, you should notice that -2 is not going to work. So -2 does not work, and our only solution is x equals 1. Okay. So this is the slide I had to re-record, unfortunately, so I'm just going to kind of wander the hallway and write as I walk, because you guys are in the classroom taking your quiz right now. So, a flight across the U.S. takes longer east to west than it does west to east. Assume that winds are constant and in the eastward direction. So basically assume that physics isn't true, because you know it wouldn't be constant and only in one direction, but still, let's just go with it. When flying westward, the headwind decreases the airplane's speed. When flying eastward, the tailwind increases the airplane's speed. The time for the round trip is shown, the round trip that's shown here is 7 3/4 hours. If the airplane cruises at 480 miles per hour, what's the speed of the wind? So first of all, we want to acknowledge that let me switch to the color and the pencil width I like. In the eastward direction, you have a tailwind. So you're going 480 miles per hour plus the wind. In the westward direction, you have a headwind. So you're going 480 minus the wind. The distance is the same in both directions, because it's 1,850 miles from San Francisco to Chicago, and the same thing in the other direction. I'm sad, I missed the music already. Now, distance is equal to rate times time. So if I solve for time, it's distance over rate. So 1850 over 480 minus x, and 1850 over 480 plus x. And when we add those two together, we get the total time, which was 7 3/4 hours. Oh, that's supposed to be a 4 hours. Now, if you go to the next slide, you will see, or if you just continue the video, of course, duh, I have to go to the next slide. You just keep watching. You'll see the equation. Okay, so our equation was, to clarify here, 1850 over 480 plus x, and 1850 over 480 minus x, and that must equal the total 7.75 hours. So the GCF here is the difference of squares, 480 squared minus x squared, because we know that's what we get if we multiply those out. So using my trusty calculator, 480 squared is 230,400. Oh, I missed the 4. 400, okay, minus x squared, and that's what we're going to multiply by the entire equation. On the left-hand side, the 480 plus x is going to cancel, so I'm going to have 1850 times 480 minus x, and then the 480 minus x will cancel in the second part, so it'll be 1850 times 480 plus x. And then on the other side, nothing cancels, we just have to multiply it out. And the numbers aren't going to be quite as horribly miserable as you think they are. So I'm just going to quietly, I'm going to stop talking for a second. I'm just going to go ahead and simplify this down and show you how it's not as ugly as you think it is. So 1850, I said I wasn't going to talk, so mum's the word. $1850x. All right, I can't do it. I can't make a video and not talk. It feels too strange. 1850x. Oh, hey, look, that's nice. The 1850x's are going to cancel. And then 7.75 times 238,400. That doesn't look right. Oh, because it's 230,400. Whoops-a-doo. 7.75 times 230,400. 1,785,600 minus 7.75x squared. All right, I'm going to get it all together on one. Oh, no, I'm not. Because look, this works out nicely. How about 888,000 times 2? All right, 1,776,000 equals 1,785,600 minus 7.75x squared. I'm going to minus the 1,785,600, 177,600, minus 1785600. Oh, that's not right. 1776000. I forgot a 0. 1785600. Okay. We're almost there, guys. Almost there. It's negative. So, all right. So this is going to come down to finding a square root on both sides, and that's nice. 7.75. All right. So I have x squared equals 1238.7. There's more decimal places, but I'm going to leave it on my screen. Do second square root, second answer. Hold on. Hold that thought. All right. Okay. Divided by negative 7.75. Okay, sorry. Had a little calculator malfunction. All right, I get plus or minus 35.2. We can't have the negative because we can't have negative speed. 35.2 miles per hour is the wind speed, and we are done. See you in class.